Alrighty, welcome back to a coding project review here on the Pewaukee YouTube channel. Today I'm joined by
Ben?
Sven. Indeed I
Yes.
am. Sven, would you like to introduce yourself? Give some
Yeah,
background
so
to the viewers.
I know nothing about programming, anything like that, and I do like the game of chess. And Karthik came to me and said, you want to do this video and you ask questions about it, and I was like, let's go.
Sven is
So
always
I'm
an
just gonna be,
intrigued man. So
yeah, I
here we
got
have the
questions.
chess game here. The general workings are that, you high or once you select any square, that square gets highlighted. And then basically, if you make a valid move, then the board flips. So the person's turn that it currently is at is always at the bottom of the screen. So it's just a way to play with your friend. Me and Sven tried playing this, or we played this once
Yeah.
earlier before. So let's take a look from line number one of the main application. So these kind of import statements are kind of like in general, they're like pots and pans when making a recipe. So it's
Mhm.
like tools, various tools that we use in order to make things we want, basically. So basically these tools are for putting the pictures of the pieces onto the board. So basically I have this piece picks folder here and it has a black bishop and all the black pieces and then it has all the white pieces. So these pieces are pictures. And I remember you asked me before, how did I get these pictures? Well,
Mhm.
basically what I did is I went on chess.com and then I just loaded up an analysis board and then I moved the piece to a square where it didn't have like a letter on it or like a number. And then basically I just did like a little snipping tool, got a picture of the square and then cropped out the extra colors using a free application called GIMP,
Okay.
GIMP. And then, so like basically this black bishop would have been on a white square, but then I went in GIMP and then kind of just removed all the white that was
Okay.
kind of
Yeah.
on the outline, and then everything else in this background basically, so that
Okay.
what is it? It wouldn't be like, you know, just the bishop with the white square.
Right.
And yeah, so these are all for putting the pictures of the pieces onto the board. Um, This here is to store the pieces variable of all the pieces. So this is just like a list kind of import. So that just is the Java array list class, and we'll look more at that later. These are imports to deal with the application, like drawing pictures and using event handlers, which we'll get more into later. So here, so we use a thing called object-oriented programming. And so for this class, or for this is a class application app extends application. So this app basically inherits uh, this application. You might ask, what does that mean? And I guess an analogy like that would be like, um, let's say like butter, for example, has milk in it. So it extends milk. So it has all those attributes of milk that you can like access. So let's say like calcium or vitamin C or
Interesting.
whatever's in the milk is in there. So similarly, our application is like a Java kind of documentation thing, or I mean, it's a bad way to say it, but a Java class that has certain functions and certain, things we can do with it. And in order to make an application, because we're using JavaFX, the JavaFX app, we need to extend application, otherwise it just won't work. All right. So here we're using three groups. These groups are basically just collections of objects we'll see later. And so if we have, let me actually just run this 1 second. So we're going to have three different groups here. We're going to have one group for all the squares. So each square has a group. We're going to have one group for all the pieces. And then we're going to have a separate group for the highlighted square. So um, basically we'll see later that this highlighted square kind of group is only going to contain one object because you're only going to be, selecting one square at a time. So you only want to highlight one square. So let's go back to top. So here it's called initializing variables. So we're saying, okay, let's make a scene. This is a type. So this is a name. So we're just saying, um, generally speaking, we're making a scene. We're making 3 groups. So the grid group is the squares, piece group is all the pieces, highlight group is the highlighted square.
Yeah.
And then the pane we're gonna kind of use as like a, how do I say, like kind of like a layout. So all these groups
Mm.
can be put onto the pane.
Okay.
And then these 3 are just definitions for adding images to the screen. So maybe these PNG images here.
So would
Um,
this be considered front end?
Front
Like
end,
like
yes,
the
yes,
imaging stuff? Okay. Okay.
yes. Um, this declaration here. We'll see about backend processes very, very
Yeah.
soon. So here we're making um, a list. This is a list here, and it's a uptype integer. So basically what happens is that every square that we click on, so let's say this square over here, this square has coordinates 0, 7, or wait, 0, 0, I meant, sorry, 0, 0, and we'll get into the coordinate axis. How about right now? So usually this point here is defined as 0, 0, but in programming, the y-axis is actually at the top of the screen. The x-axis is at the top of the
Yeah.
screen. So basically this point here, or technically this point here, the tippity top left of the window is the coordinate point 0, 0. And as you go farther to the right, the x value increases, and as you go farther down, the y value increases. So basically what we want to do with that coordinates list is find out which square is clicked, basically by finding the coordinates, which we'll see later, and then converting that into just like a simple number. So take, for example, this right here. I believe where my mouse is right now is something like 30, 30 xy coordinates. But we want to say, okay, instead um, it's kind of this 0, 0 square instead of 30, 30.
Right. That
And then I'll
makes
make
sense.
things a bit easier moving forward. So here we have a list of pieces to easily access every piece. We'll see later why that's very important to access every piece. And we're also going to declare a king. And so Sven, you know this. So let's say we make some moves here. Let's say we do something like this. And let's say the queen goes out here. So for example, if we're in white's position, the reason that we set these kings, we'll see later as well, is that let's say we select this piece, obviously we can't move this piece, right? Because otherwise our king would be in check. So basically what it sees is that if you select a piece, when you're setting the moves, you want to make sure that none of those moves results in a check. So you'll see if I try and move this piece, oh, I can't do it. I can't do it, it doesn't let me. Want to move this piece? Oh, it doesn't work. That's not good. Oops, wait, what's happening? I can't move anything.
I think it's.
I think it's
Oh,
thinking I'm
there's
in
one.
check. That's not good. Uh-oh.
Maybe.
Cut this far out, cut this far out. Well, there's something wrong then. Uh-oh. Well, that's no good. Huh.
Wait, is it black to move?
No, because white's on the bottom. So I don't know what exactly is
Oh
happening
yeah.
here. I feel like let me see something. Um,
This is raw content, like night.
this is not great, but you know what? It's all right.
Well, it's good though. It's like you can go through your process of what maybe you think is
Well,
wrong.
I know what the problem is that it's thinking that this piece isn't here. It's hard to
Oh,
explain, but I believe that's what the issue is. So let's take a look in. So in uh, then it gets added, but then it doesn't. Yikes, I don't even know. So hold on. So this is technically gonna go down left. So we look down left would be here, and then okay, and then down left just falls. But I don't know why it doesn't work then, because you're not in check though. And look, okay, and then that's strange. That's really strange. Well, why is it happening?
Now I'm curious.
Yeah, I am too. I thought I had this problem solved actually. Funny enough. um, uh, so it's something here, right? So what happens is when we're setting the moves for the opposing queen, something is getting wrong where it's saying that it's in check. So let's just make a quick print statement. Let's say in check. We're just gonna say piece dot type, which we'll see later on. And let's see. So it should say that I'm in check when I'm actually not. So let's do something like this and then in check by bishop. I'm gonna lose it, Sven. Yeah, I'm already gonna lose it. In check by what bishop? Hold on, this has to be. This is something else. Let's see what the color is of that bishop. It better be like black, otherwise I don't even know. Oh wait, I'll do that. Um, nothing was printed. Hello? Oh wait, queen black. Now it's the queen. What did I do differently the other time? I don't know. So now it's saying the black queen. Okay, but it's not. That's very strange. Or if we're to say, I don't know, it's very strange. So then the king can't even move? You're telling me the king has no moves? Okay, apparently the game is over, so I don't know why that happens. What? Dude, that's crazy. I thought I had this all figured out. Oh my god. Alright, hold on. So, see, there was a major problem here, which I fixed, but I thought it should be fixed. So I'm a bit confused.
Imagine coding a chess engine, like all the moves, like.
Yeah, that's crazy. But see, so what happens is, right, we have, oh whoops, we have I need to run this again. Let me just do a quick run. So what happens is when we do this, let's say we do this here, and then we move the queen out. It's saying in check by the bishop black. That's if the bishop goes here though, and then checks me. That's strange, actually.
And you can't move your king.
Because it's saying I'm in check by the bishop, which would move here, yeah, but that's not even actually what's checked, because what's checked is that the piece equals the king's location. That's what it's saying. So if the bishop goes here, sure, it checks the king, but it's not equal to the king's location. So...
Wait, try moving the pawn to block that theoretical bishop.
That didn't work. Oh yeah, okay. Yeah, I got you. I heard. I don't know. Hold on, I'll be right back actually. Alright, hello, it's Pewaukee from the future, and I'm here to say that what you'll see in the next edit is me moving the, where is it, the to move function call. So here you'll see to move is defined here. Now this is the correct spot, I believe, but it was defined in the for loop, in this for loop, when it was supposed to be defined outside. That's the change that's being made. Alright, on with the video. Oh, this doesn't need to be in here. Could it be here? I don't know if that's the move, but let me see. So if we just select a bunch of random pieces, let's try and move something else. Okay. Let's try and do that again. That sequence. Go here. Then I can't move that. Oh, wait, what?
Hmm.
So I don't know what I just did. Okay, we're
Mhm.
starting. Alright, so where we left off, might have a funny edit there, but I'm not sure yet. Okay, we left off here. So storing the current turn as a string. A string is basically just like a set of letters like this, ABC, for example. Could be anything else. So basically, we're gonna change this in the program after every move happens. You know, so if it's white, it's black. If it's black, it's white. Simple enough. Okay. Now this, we'll dive into this later actually. So we're not gonna worry about that right now. This one is interesting because I felt I had to implement this in order to call one of my functions from a different class. So basically, this p here is used to call a method called isOccupied.
So that's like you
Uh,
can't move a piece or pieces if you're not capturing it, or
what do you say?
does that like have to do with like if a square is occupied, you can't move the piece that's square? Or...
Yeah, basically. Or actually, no, this one just checks if the piece has a piece, if the square has a piece, excuse me.
Mm,
So basically, if we run this again, so if we run the function on this square, it's going to say yes, that is occupied, so it's going to return true. If we do it on this square, for example, it's going to return false because there's no piece there for anybody. So this is, we'll look into this later. This is a bit complicated even for me as to why I have to do this, but okay. All right, En Passant. I know you like En
ah,
Passant, so
yes.
En Passant is I store it as an integer because, well, as a number. We'll look into that later, actually. So here are all the file strings. So we need these file strings along with this to add in an image. We'll see how
Okay.
that works later. So now, basically, we're going to go down. So what happens in a Java program, Sven, is that once you run the function, or once you run the program, excuse me, we automatically go into main. So main is what's run first in Java, and that calls the launch function, which for an application, which was extended here, that basically calls the start method. That's kind of the general idea to
Mm,
that. So we're gonna start here. So now what we're doing is called assignment. So we're going to assign each group to be a new group, and then we're going to have the pane, which remember we said makes the what am I saying? Makes all the groups visible on the screen.
right.
Okay. So now here we're going to construct the board. So the board is basically, just this combination of white and blue squares. And basically what we're doing is we're running this kind of loop here 64 times. And so basically what we're doing is we are saying, okay, make a rectangle and then set its x coordinates to be, oh, we'll look into this very soon. Set its x and y coordinates and then set its width and height. And
Okay.
basically what this says is that this here, this kind of percent sign, basically just means remainder. So if we say count percent sign 2, which is known as modulo, basically it finds the remainder when dividing by 2. So if that is equal to 0, which means an even number, we're just going to say, okay, set the um, color of that rectangle to be white. Otherwise, set it to be uh, light blue. This is an RBG
Mhm.
kind of makeup of light blue.
Yeah, this makes sense.
And then this part here, so remember that grid group we said? That contains all
Mhm.
these squares. So we're gonna add it. So we're gonna add the rectangle. So basically when this runs, for 64 times we're adding this rectangle, then this one, this. Maybe not that order, but all the
Yeah.
squares get added. And so here, this one here, let's take a look at this. Coordinates equals coordinate formula. So remember coordinates was this list here of integers, which is just numbers. Or integer just means a whole number. That's all that means.
Yeah.
Okay, and then let's take a look at this coordinate formula. So let's search it up. I have no idea where it actually is in this thing. It's probably like at the bottom. Here it is. So basically what this does is, so remember we talked about this is 0, 0.
Yeah.
So this would be 1, 0, and then 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, until you get down here, which would be 7, comma 7. So
Yeah.
basically, when we insert a rectangle into the screen, when we do set x and set y, we can't say 0, 1, 2, 3, 4, 5, 6, 7. We can't do that. We need to have the pixel number, basically. So we need to say for 0, 0, the top left corner of this is at 25, 25. So that means 25 pixels and 25 pixels from the edge of the screen and the top of the screen. So that's what we're saying here, is that um, basically the kind of offset is 25. So it's 25 from the edge. You can kind of see this gap here. And
Yeah.
it's 25 from the top too. So basically what we're saying is, well, when you insert a rectangle, you're inserting based off of where the top left corner is. So let's say you're inserting this rectangle. You
Mhm.
need to get this point here and then insert it. So it kind
So
of spans like this way.
if you wanted to make that, so technically you made like a border, right? Like around it.
Yes, with the width and height. That's right.
And if you wanted to make the border black, would you pretty much just have to do the same thing, but then just put the coordinates for the ones outside of what you did?
I believe there's like a special kind of thing you can do. So
Oh,
let me think. Or let's finish up this right now. So basically,
yeah,
it just goes through, and since each width and height is 100, we just want to set the spacing by 100. So if we're here at 25, 25, okay, then the next one should be at 125 and 25. So that
yeah.
it's 100 away, and then we kind of meet this width of the rectangle. So, okay, back up to where we were. I believe you can just say like r dot set border. No. Uh, r dot border? No. Mm, I actually don't know. I think there's something like a border thing that you can do. Set. We can scroll through. We can kind of find. We can maybe find something. Um, set stroke. I don't know what exactly that does. Um, maybe it's set stroke. I'm not quite sure. Or let's try set stroke and let's see what happens. Let's just say color dot black. Let's just see. So if you run this, let's see what set stroke does. Oh,
That's so cool.
okay, that makes it a lot cooler. We're gonna add that. Okay, so I guess that kind of makes that little border. That's
Yeah.
pretty rad, actually. All right, cool. Thank you for the suggestions, Finn.
Yep.
Okay, so basically, that's what we're doing here. We're drawing these, you know, this outline of all the squares, or I guess they are squares because they have the same width and height. But
Yeah.
okay, so here, when we're doing this, we're making this count variable. And basically what that means is that, so let's say we start here, right? The count is initially 0, so we're going to make it a white square. And then let's say we go into this one, but we added 1. That means that the count is 1, which means it's an odd number. So it'll run this line here. That's basically the concept of why you have to kind of make a variable like this and then see if it's an odd or even number, and then just, you know, do some color. That's basically
Yeah,
it.
yeah.
So at least for that. Okay, now we call a function called setUpPieces. So that will be right here. And so let's read. The purpose is to set up all the pieces with the respective coordinates, color, and actually we don't set the available moves here. So we're gonna say, we're gonna get that out of there. And then we're gonna say, we're gonna have to set the white king and black king accordingly. So basically what we're doing here is we're doing the same looping and to go through all the squares. Oh, I keep exiting this thing. So we're doing the same looping to go through all the squares. So let's move this over here. Or let's just do it over here. So we're doing the same looping. So this basically means that loop 64 times. So we're going through all the squares. Kind of like, let's see, how does it work? We're actually going in this fashion. So we're going down like this through all the squares. So basically what we want to say is that, so here I is the x coordinate and j is the y coordinate, we can say for simplicity. So we start at 0, 0. And basically, if j is 0, that means it's the 8th rank. So that means it's this 8th rank up here, because that
Yep.
means the y coordinate is 0. So now, if the j coordinate is 0, which means we're the 8th rank, then we have all these kind of conditions here. So if I is 0, I is 7. So let's go through the general idea of all these if statements here. So they basically mean if I is 0 or 7. This here means or. I'll explain that to you. So if it's here or here, we want to insert a black rook. If it's here or here, we want to insert the black knight. If it's here or here, we want to insert the bishop, black bishop. If the selected thing is here, we want to insert the queen. And if the selected thing is here, we want to insert the king. And that basically happens here in these lines. So if I is 3, that means x is 3. So if we look 0, 1, 2, 3, so that means that queen is going to be the 3rd. Or I guess the x value of the queen in terms of coordinates would be 3.
Yeah.
And so basically what we're doing here is we're creating objects. So we're creating an object of a rook, right? So and this object of rook has, or let's say when we create this rook. So like for example, let's go through one of these. So right here. So we have piece equals new piece, IJ black rook and black rook file string. So basically when we make a new piece and we have something like piece here in this capital, we're calling this. And we're using what's called a constructor. So this here is a constructor. So a constructor basically is like, let's see if I can make a recipe analogy. A constructor is like kind of the, how do I say, the oven to the frozen pizza maybe? Because let's say you put the pizza in, right? And then
Yeah.
you say, okay, this pizza now has an attribute that it's in the oven, okay? And
Yeah.
that means that we could say like, we could have a variable, and we could say like, is inside the oven, and we can set that to true, because it's in the oven, right? So similarly,
Right.
the rook here is at this certain coordinate place, so 0, 0. So basically the super here, let's explain that super. Super means, so here in piece, we extend location. So what does that mean? So we have another location file here. And what this location file is it's basically just has an x and a y. Simple enough. It also has a distance formula, which we'll get into later, and inbounds we'll get into later as well. So basically the rook kind of, when we call super, we call this constructor. So basically meaning that the x coordinate is equal to x, which is seen here, and the y coordinates equal to y. So it's just saying 0 equals 0 and, 0 equals 0 again.
Yeah, yeah.
And then we're setting the color equal to the color provided here. So this dot color, all these thises you see, this refers to the object. So if we take a look here, piece is going to be this. So we're saying piece's attribute of color is equal to the argument color we're given here. So the argument color would be black in this case, because if we're at 0, 0, it's a black rook. And then
Yeah.
the type. So the type, this dot alive, we're going to be seeing that later. So I'll explain that later. But every piece is set to being alive because no piece is dead. Simple enough, I
True.
guess. And at least at the start of the game. And then this dot type equals type, so the type of the rook is type rook. And that'll be used for setting the moves in the future, we'll see. So the final thing is the black rook file string. So we have the string file name, and this dot file name is equal to file name. Put simply, it just means that this attribute or this object has an attribute of having this picture,
Okay. I was gonna ask how they're linked, how you made it so that they're.
Yeah, so basically, we'll look later. Every time you draw the board, it's kind of getting this file name attribute. So it's getting the piece and it's saying, okay, where is the piece located? Is X and Y. What's the type? Or actually, it just says where is it located and what's the file name. That's it. Simple enough. Because then it says, okay, at this certain location, just put the black rook or just put the white king, for example.
Yeah, yeah.
Okay, and then here. So if the object is either a king or a rook, we need to set a has moved variable, and this is for castling. So basically, if we move the rook at any time, we don't want to castle, or it's not allowed to castle. So let's do a quick example. If I just do this, and then I do this, and then this, and then let's say I move the king, and then I move him back, and then I want to castle. Oop, I can't castle. So that's
Yeah.
why we need the has moved variable to make sure about castling. But that's only
So
applicable
essentially,
for a king and a rook. Yeah. So
you're giving it like a restriction, pretty much.
yes. So also, if it's a king, we need to set a checking variable.
Right.
Otherwise, we don't need to. So basically, that's what all this does. And then if we look here, if j is equal to 7, it's or actually, let's look at the pawns. So pawns here. So basically, if let's see, if j is equal to 1, which means it's the first row, or this row. Yeah,
Yeah.
this row. Then we just put all pawns. Right, so
Yeah.
if it's the, oops. So if it's the sixth row, then we put all white pawns. And then here, if j equals 7, that's the first rank. So then we basically do the same thing. So we put the rooks at the ends, the knights not at the end, and then I guess just the pieces where they need to be. Basically
Yeah.
so that the kings look at each other. Yeah. And then we add it to the piece list. So remember we had the pieces list, which was defined up here.
Yep.
Alrighty. And now, so once we're done with that, we're going to draw the board. Let's go there. Draw board. There it is. Okay. So all this says is that for each piece in that list that we just put all the pieces in, we want to set the image of that piece, which is right here down below. So
Okay.
in the set image, we're saying, okay, we have 3 arguments. So let's look here. We have 3 arguments. We have path name, we have I, and we have j. So we're just going to want to say, okay, for each piece, we want to get the file string. So this will be the string of whatever file it was. So if we had a rook, right, then this file name here would be the black rook file string.
Yep.
And then we're gonna say, okay, get the file string, get the location, get the x coordinate of the location and the y coordinate, which is gonna be I and j. It's gonna be passed in like that. So it makes some arrows like that, and then like that, and like that passed in. So now what we're gonna do is we're going to use those image variables we defined earlier. We're gonna set them equal to, so we're gonna have the path name, the stream, input as image, and then the image view as a new image view. Basically, all of this I don't fully understand. So this is where you think of like backend stuff. So for example, like
Okay.
set image, that's gonna be a function call, but I don't control that function. It just does it for me. So that's
Okay.
backend. I don't know really what happens there. But as
Yeah.
in coordinate formula, I implemented that. So I said, okay, do this. But here, when it says set image, so when it has this kind of function encased in parentheses, that or when it has this kind of thing here encased in parentheses, so if we just say like something like function, so we have something encased in parentheses, that means it's a function. Or we
Okay.
have those set of parentheses there, and you might have something in it, or you might just have like two parentheses empty. So that's just a function. Or so here, all these are constructors actually, because we have this new keyword. But if we're saying set image, then we're having a function, which is
Right.
of image view, basically. So it might be a little hard to understand, but
A little bit. I mean, I kind of understand it.
yeah, so basically the set image is a function that belongs to this class of image
Right.
view. And yeah, that's backend. I don't know exactly what happens there. Um, you're asking about front end and back end like that. So
Yeah.
then we're gonna say, okay, image view dot set x and set y. This basically just says set the coordinate or set the picture's coordinates to be whatever the coordinate formula is, um, which is just that same thing of like, you need this top left thing, and then you span the image like this kind of.
Yeah.
And now we're gonna say piece group dot get children dot add. So we're gonna add that image view into the piece group. So remember we had that grid group, which is all the grids,
Yeah.
all
Yeah.
the rectangles, and now we have piece group, which is all the, all the pieces.
And
Okay.
did you have to set like the coordinates for the piece specifically, or does it kind of just auto do it if you select the square? Like centers
Um,
it?
it it doesn't really center it. So let's say, um, I did have to set it manually because I wasn't quite sure how to center it. So let's say if we go,
Like what if you wanted to tilt one of the pieces?
ah, I don't know how to do that, but let's say if I did 1,000 by 1,000, we would have, I think we would have some issues, maybe. Oh no, excuse me, not that. Let's go back to 850, 850. If I were to say, what was it? Actually, it's just because of the coordinate formula that the certain piece kind of goes there. So
Okay.
like because of that coordinate formula function that I made, that basically just means that our image here is going to be put right here.
Right.
Or
So it's like
for
a parameter.
example, yeah, so let's say instead I said what if I set the width to be different? So let's say I said 150. The problem with this now is that these pieces are not going to be aligned at all. They
Uh,
are. What? I
okay.
thought
Yeah.
they
You
would
kind of
be.
did move it a little bit.
I thought it'd be wrong, but maybe I was wrong. Oh, if I change everything. So let's say if I say 100 to 150. So I replace all those. And then we run it, then we're gonna have some problems. Because
Oh
what the
yeah.
heck is that, right? So each of these pictures has a certain kind of, length. Or I guess
Yeah.
this could
Yeah.
be width and this could be length, it doesn't matter really. but you kind of have to adjust for that. So otherwise you have to do, you have to rescale this. So like you'd have to rescale this rook to be like bigger. And I wasn't
Right.
quite sure how to do that. I probably could figure it out, but I wasn't sure. So now
Yeah, yeah.
let's reset those. 200. Okay. And now let's just make sure everything's hasn't blown up. Nice. All right.
Training.
So after putting all the pieces, then we are going to we're here. So we're going to declare a scene. So the scene is kind of just the screen, simple enough or simply enough.
Mhm.
So I mean that's also kind of the stage. It's hard for me to explain exactly, but basically it makes a new scene object. So anytime you see new, you're making like an object. So it's new and then scene, and then we have that pane we defined earlier, and these are the dimensions of the screen, 850 by 850. And then we're going to use the stage, and we're going to set the scene, set the title. We're going to make the window not resizable, and then we're just going to show, which means just like make it a screen, basically, or have it pop
Yeah.
up. So now we're going to start game. Start game is here. And so we're just going to set the turn to white. And now we get on to the fun stuff. So actually moving the pieces. So
Wait, I
basically,
have a quick question.
yeah.
When you said, how does it know, like, when you say turn equals white, how does it know, like, what the turn is?
So turn is defined. That's a good question actually, because if I hadn't defined, let's say, or in order to see what turn is, it has to be defined here.
Oh, okay,
So
I
this
see.
is kind of like it's called global scope.
Hmm.
And say if I were to make turn in here when I just started. So if I let's say I cut this or cut that and then brought it in here. Now if we go down here, it's gonna say I don't know what turn is.
Oh,
So
okay.
because it's only defined in this function here. So it's only
Okay.
defined for the start function. That's what it's called. That's what's called a local variable. So a local
Hmm.
variable, if the local variable is placed here, if the var is here, then it can only be accessed in this function.
Right.
But if
Okay.
it's in here, then it can be accessed by this whole class. So that's what we want. Because in the
Yeah.
class thing, instead of a function. So let's go back to here. So now scene set on mouse clicked. So now we have something called an event handler. An event handler handles user input, and that could either be uh, like a button clicking, or like keyboard clicking, or like a mouse click, or something like this. So we're gonna say set on mouse clicked. So what we'll see is what happens is that if all this means is that I click on the screen, it doesn't mean I clicked and released. All it means is that I clicked. So what I'm gonna do,
Hmm.
if I click, I need to release it. Never mind, that was completely wrong. If I
Mhm.
say pressed, set on mouse pressed, that means that I can hold it and it'll happen. So I hold, I'm not letting go of my mouse right now.
Yeah.
And if I let go, nothing's gonna happen, but basically it's just the difference in whether you can press and hold it and it'll still do the action, or if you actually need to do a full click. So the full click will be that you clicked it and let go, which is how I want to do this.
Yeah.
So basically, you just use the scene variable. So the scene variable is defined like here, right? So it's accessible throughout the whole class. That's what we want. Go back to, okay, here. So now, handle. So handle is basically what happens is the function that's run when the mouse is clicked. So we're gonna get the X and Y coordinates. So we're gonna say event. So we have mouse event event, and that basically just means that whenever we click the screen, we get an event object. And in that event object, we can get the X coordinate, we can get the Y coordinate, and then we can do what's another function called find square. So find square is the opposite of find square. Find square is the opposite of uh where is it? I believe it was here, coordinate formula. It's the opposite. So coordinate formula says, okay, uh we're given this here 0, 0, and we want to transition that to x and y coordinates. So the other one gets square or find square says, okay, we're given, let's say my mouse is here. This is going
Yeah.
to be like a coordinates of like, I don't know, let's just say 500 and 450. And what we want to do is we want to get that square. So this square would be 4, 4. So we want to get that square coordinates instead of the actual coordinates. So that's what
Right.
we're going to do here. That's what we're going to do here. And then we're just going to set x and y to be those coordinates. We're just going to kind of redefine them. Highlight square. So highlight square, let's go to that.
I was gonna ask if you assigned it to like a meaning.
Highlight square.
Yeah.
So highlight square is a function. Um, remember that when we have this kind of like parenthesis thing,
Mm.
it's a function. So we're calling the function with this x number and this y number. So basically what highlight square does, all it does is that, simply put, because I think we need to maybe speed it up a little bit. Simply put, is that it highlights the square. So it makes a rectangle and it makes it a green color. This is a kind of greenish color. And then it just sets the opacity a little bit low so that, you know, if the opacity was 1, it would just cover the whole pond, which we don't want. We want to see the pond
Right.
still. But
And wait, did you define the colors with numbers, or is that RGB?
I can
The green.
say green as well,
Okay.
and we'll see the similar thing. So it'll still be
Okay.
green.
Gotcha.
But yeah, this just, RGB just is red, green, and blue. So all this means is that it's fully green. So it's the same thing. I'll just say color.green for simplicity. Okay, and then we're gonna set the king. So when we set the king like this, we want it to be this whole question mark thing just basically means, so the king, if the turn is white, it's the white king. If the turn is black, it's the black king. That's all that means. So here, to move. So if not to move. So this exclamation point means that not. It means not. So to move is a Boolean which either says true or false. So if you think like binary,
Yeah.
binary in binary 1 is true, 0 is false. So that's basically all that the Boolean kind of stores. It's not necessarily a number, it's just the true or false thing. So basically, originally, when we look at to move was originally set as false. If we go back, I believe it was set as false. Okay, maybe not. Maybe it was not set. That's strange then. Should be false. Let's actually set it to be false. Because we need to select a piece in order to move, right?
Right.
Makes enough
Yeah.
sense, I think. So originally it's false, and then if that happens, then we're gonna say to move equals set piece. So that'll be down here. So set pieces again is a function. Where is it? Set piece right here. So what we're gonna say is that if, okay, so we have this, remember this P, this kind of like placeholder piece I talked about?
Yeah.
So we can't do this. That gives an error. So it says is undefined for the type app. So what this is saying is that this function here, if I were to say, if I were to make a new function, that's fine. Or I guess technically it doesn't have the correct arguments. If I were to say this, that's, well, actually that's, okay, hold on. Okay, you know what? This is getting a little bit confusing because there's too many things to kind of change. But basically, if we had an isOccupied function in this class, so in this file, this is fine. But we don't. It's only in here. So it's only in this other file. So occupied is only here in this file. So we need to use like this kind of placeholder piece because this placeholder piece has no impact on whether or on the result of piece. So basically all we're doing is we're saying, okay, let's say we select this square. All it's
Yeah.
saying is that this piece is equal to whatever piece is occupied here, if there is one.
Yeah. Yeah.
Okay, so we're gonna say if the color of the piece is equal to the turn, we're gonna say that the current piece is equal to the piece. So current piece. Current piece is a variable set up here, I believe. Here it is. So current piece just basically is saying like this is the current piece that we're using and that we've set it to. So let's see if it can move basically.
Yeah.
Kind of idea. It's a lot of things. Let me just go back to where we were. All right. So now we're going to say we want to set the available moves for that piece. So let's go into set moves. Actually, let's worry about set moves later. Okay. Now we have this special case here. So this is the en passant
Comfortable?
case.
Yes.
So if the current piece, so after setting the moves, the problem with trying to set moves is that I call one function and then based upon whatever piece type it is, it runs a certain other function. So I call a function called set moves. Let's say we're on a pawn, it'll say, okay, do the pawn moves. Let's say we're on a rook, it'll say do the rook moves. Queen, it'll say do the queen moves, and so forth. The problem with en passant is that you can't really pass in the en passant variable into the function. So it's into the set moves function. It's a little bit weird.
Yeah.
So you need to do kind of a special check. So we're going to say if the en passant is not equal to 1 and if the current piece dot y is equal to 3. So basically all this means is that, let's make an en passant scenario here. If if the current piece's y value is 3, right? So 0, 1, 2, 3, it's on this third row. Only
Yeah.
then can you actually en passant. That's the only way it ever works, right? So we're going to say if all these things are true, so if en passant is not equal to -1, so basically here en passant is equal to 7 because this pawn is in the 7th column and
Yeah.
can be en passanted. Is
Right.
basically what that means. Because we'll see later, like if the pawn moves up 2, we're going to set the en passant variable to be that column number.
Okay.
And then we're going to say, yeah, then we're going to say, okay, if that's true, then we add the move of en passanting, and hopefully it works. Hey, there we
Hmm.
go. Okay,
Yeah.
so, okay, so that's a set piece function. So let's go back. So if you select a piece that matches your move, right, then you're gonna say, okay, set that piece, and let's see if it can, be moved. Let's see if it's even equal to the current turn's color, right? So if you know, right now it's black's turn, so if you select the white piece, you're not gonna be able to move it,
Yeah.
you're not gonna be able to move anything. So that's the general idea of set piece. So now if toMove is true, because here we return true and then we set that variable equal to toMove, then what happens is we want to see on our next click. So let's go through a run through. So let's say we select this pawn. So now it's going to say, okay, great, you selected this pawn. Now the toMove variable is true. So when you click the next time, it's going to go here. It's going to say, okay, toMove is true. It is not false. So we're going to
Yeah.
say, okay, let's go into here, into this block. So now remember how we said set moves to set the moves of a piece?
Yeah.
So now we're going to say, okay, get all the moves of that piece. So we're just,
All the available place. There we
yes.
go.
So all these available places, so you say, okay, what is this location, colon, curvy stack and move. So what this means is that for each location in the available moves, so let's say you have this bishop here. So if we select that bishop, we're going to say, for each location you can move in that the current piece can move. So that basically means, okay, the bishop can move here and here. So now when we click next, basically what it's going to say is that if the place where you clicked, so let's say we click here on this pawn, if it's in the available moves of the bishop, we want to move the bishop there. That's what generally this is saying.
Yeah.
Okay, so we're going to say, okay, if there's an occupied piece, so let's say we move the bishop to take the pawn. That's the piece, that's the move we'll do. So if there's an occupied piece there, then we want to remove that piece. So we basically want to kill it, right? Because we're saying, okay, the bishop is moving to the pawn, so the pawn should be deactivated, right? It shouldn't even be alive. So that's what we're
Right.
going to do. And then we're going to say, this is a special check here. So we're just going to say if it's either a rook or a king that you moved. So let's say I moved this rook to take the pawn. Now I cannot castle kingside, right? Simple enough.
Yeah. Yeah.
Because I've moved the rook already, so obviously can't castle. So now we are going to call another function. So we're going to say check if the king has castled. So let's go there.
Yeah. Also, Rad's gonna be here in like 30 minutes, just so you know.
Okay, cool. I shall maybe go a little bit faster.
I mean, yeah. I mean, you could take your time, and then we can also just
We
do a two
can do it
part.
again. Yeah, because I need to edit
Yeah.
this a little bit too, actually. Okay, so we're going to check castle. So all this means, simply put, is that we can kind of just read this purpose statement here. This function
Hmm.
checks to see if the king has castled, and if so, we need to see where the rook should move, because when you move queenside or kingside, the rook is kind of it moves differently, right? So if we
Hmm.
castle kingside, the rook moves two places over. If we castle queenside, the rook moves 3 squares over. Okay, and
Yeah.
then we're going to check en passant. So simply speaking, all it does is just check if an en passant has occurred. That's all it does. And if
Okay.
it has, then we want to, because the thing is, when we take, so let's run this again. So when we take here, oh, that wasn't right, but let's just do, so if we move this one up, when we take, there's no actual piece here. So you need to
Yeah.
make a special check and say, okay, you have to remove this piece here. Does that make sense?
Yeah. Yeah.
So that's why, that's basically the special check
Is
that we
is
need
it
to do.
also treating is it also treating it like that pieces in both squares for that pawn specifically?
For the black pawn that we took,
Yeah.
no, that black pawn's position was here.
Okay.
But that's just, we make this kind of special case because think about this. So if the black pawn was here, there can be no other pawn on this column and this row.
Right.
So we just say, okay, delete that pawn. Just
Yeah,
get
that
it
makes
out.
sense.
Simple enough. Um, so it was kind of hard to think about that. Like, how do I remove that piece if it's not actually there? Um,
Yeah.
so yeah, that's a general idea about that. So we say, okay, since the pawn can only be en passanted here, right? Because it has to be on this row, because the black pawns have to move up to this row in order to be en passanted,
Right.
then it's, easier to check, if that makes sense. So
Yeah. Yeah.
now when all these two statements are doing is saying we're just going to remove all the pieces and remove the highlighted square because we're going to add them later. Okay, so now we're going to say if the turn is white, then the turn is black. That's what this says. So if we're
Okay.
just going to switch the turn variable. And then if the king, we're just going to set the king variable again. I believed it. Oh, it's already done at the start, so I actually don't know if we need to do that again. I don't think so. I think it's a bit overkill. I'm just gonna leave it in there for now though. And then we're gonna say, okay, king.check is equal to king.incheck. So it's just gonna see if the king is in check. So it's gonna say king.check is either true or false. And then we're gonna say check the conditions. So this looks for a stalemate or a checkmate. So let's go here. So check conditions. This is just the game conditions. And we're just gonna say if the king is in checkmate. So those are functions defined here. If the king is in checkmate, or if the game is in checkmate for one person, or it's in stalemate, then we're gonna print that out, and the game is gonna stop.
Yeah.
Um, or the game doesn't really close. It's just that you have no moves, so the game just stops, or you can't do
And
anything,
did
basically.
you set did you set checkmate to when the king has no more available moves?
Oh yeah. We can take a look at that actually. So basically, let's say it was black's turn, right?
Yeah.
So let's say black made a move. Okay, now it's white's turn. So now we take a look and we say for any given turn, if there are no more turns for all of the pieces and the king is in check, then it's checkmate. So let's say we can make a very quick checkmate here um, just by exposing this king. Excuse me. Jeez.
Mhm.
We can just do this and then we can do something like this and then there. So that's checkmate. So
Yeah.
basically what it says is that, okay, now it's white's turn. White has no moves to get itself out of check.
Right.
So this basically says for each piece, if the piece's color is equal to the turn, so in this case white, then we're
Hmm.
gonna say, okay, get all the moves that you can while looking for a check, and then add that to it, a number variable. And so basically,
Right.
what'll happen is that the counter, which is counting how many moves there are, so it's saying counter plus the piece's moves dot size, so that basically just says how many moves the piece has. If that's 0 and the king is in check, we return true, so we say yes, it is a checkmate. The only difference in stalemate is that if the king is not in check. That's the only
Right. Right.
difference. So now we can uh um this should have printed here actually checkmate for black, but that's okay. um Perhaps I've done something wrong, but it's okay. Uh Now let's go back to piece. I might have to, or to app. I might have to look at that later. And then now we're going to go back to here. Now we're going to flip the board. I know, very good comment. Makes the
I
game much
was
cooler.
about to, I was about to say that.
So we're going to say flip board, which is here. Okay. So you might be saying, what is all this? I'm seeing a bunch of adds and subtracts. So basically, in
Yep.
order to flip a board, you need to flip along this axis, the horizontal or the vertical axis, and the horizontal axis. So that's what I'm doing here in short. So you kind of have to flip along a square. So flip along this third column or the fourth column or
Yeah.
the you know or the third column or the fourth. This is the row. Third row or the fourth column. So it's kind of weird. It's kind of a
Hmm.
weird type of let's say for, if we run again and we say, okay, we move this up here, then, or if we move this piece here, then this black pawn is going to be flipped this way and then flipped this way. So we can
Yeah.
see that
Yeah.
pawn there. So that's generally the process. It's just kind of like testing, trial and error, just seeing
I
how
was
the
about to
board
say that must
flips.
be really confusing to calculate that.
Yeah. And so basically what we're going to do after that is we're gonna try and draw the board again. So we're just gonna say, since we erased all the pieces, here we need to uh, draw all the pieces again. So basically, after every move, we delete all the pieces on the screen and then add them all again. So basically, in that process, all the pieces were deleted and
Mhm.
all of the, how do I say, what am I trying to say? Or all the pieces were like flipped.
Yeah.
And then, yeah, I believe that's mainly it for this file. Um,
So much code.
yeah, that's it for this file, and we're gotta go on to piece now. So piece, we looked at the constructor, right? And
Hmm.
we we have all these variables here. So remember, these variables again can be accessed from any part of the class.
Right.
So all these variables here, and what we're gonna say is, or I guess another thing we have to do is, um, you remember get moves, right? We had called like
Yeah.
piece.get moves. So basically what this does, it returns the moves so that we can access them. So basically
Mm.
what these are called is getter and setter methods. So it says here. So it can get the attributes of an object and set the attributes of an object. So if we say like in a recipe, we say get, then we say kind of like what are the ingredients of this
Right.
soup or something. If we say set, then we want to say, okay, set the ingredients of this soup, add in some salt, some pepper, these
Yeah.
types of things. So that's basically what these are here. So we can get the file string, get the color, we can set the file string, we can get the alive status, the type, and the moves. Okay, so add move, this is for En Passant. So the problem with En Passant, it's an interesting problem, is that, let's take a look at an example. Um, oh wait, that's actually not the problem with En Passant. That's not the problem. It's a problem of pawn checks. You'll see very soon.
Uh,
It's a very weird thing. So let's demonstrate that now. So if we had a pawn check, so let's say we move this pawn, and we're on our way to check the king. So what would happen originally is I would do this, and then so you know how the board flips, right? So
mm,
all the
yeah.
pawns move up. The problem is though, if you're a king and you're being checked by a pawn, the pawn's not checking you up, it's checking you down. So
Uh,
I had to make a kind of different formula to say, okay, if it's a pawn, we need to run a different function to see if it's
yeah.
checking the king. Because otherwise, you could literally just ignore this. You could like develop a knight or something. It'd be like, bro, if your king's gonna die, it didn't matter. Um, so I was like, that's wrong. So then I fixed that, and then okay, let's go into the juicy one of set move. Wait, okay, this is also for. Oh, this is the set moves for the Oops. This is the set moves for the pawn check. So basically, when you're setting moves for a pawn check, you're just looking at the opponent's moves. So if it's a pawn, you don't actually need to check the down move because it's not a check. Because you don't
Mm,
actually take with the pawn like that. So all you need to do is check this down move and check this down move to make sure that the king is not in check. Now we go to set moves, general set moves. So basically, we have this huge statement here. Alright, so this is what we call a switch statement. So piece.type. So piece.type can either be pawn, knight, bishop, rook, queen, king. And what that means is that, okay, if it's a pawn, then we want to run this function. If it's a knight, we want to run the knight moves, bishop, bishop moves, and so on and so forth. And now we'll take a look at the pawn moves. So the pawn moves, purpose find all available pawn moves. This is a lot easier when the board flips, right? Because the pawn only goes up regardless of color. So
right.
if the board was like this, then I need to say, okay, if the color is black, you can move two up. If the color is white, you can move two down. So it's confusing like that because you had to make separate kind of evaluations.
Yeah.
and that wasn't ideal. So we're just going to say up 1. So we can move up 1. So this y minus 1, remember that the y axis is, or the x axis is up here. So
Yeah.
this is where y equals 0. So when we move up, we're moving towards that axis. So we want to subtract.
Yeah, that makes sense.
Okay, and then basically it just says this res here, all this res means is just result. I just
Okay.
uh, don't say result, I guess.
Yeah.
So basically we go, if we can go up 1, so if this y is greater than 0, that just means that you haven't reached the end yet. Oh, I believe we didn't even check the promotion here. Piece promotion.
Oh yeah.
Check promotion. That's what it was. So basically it's only for a pawn. Um, and it automatically turns to a queen, although you should either be able to choose a queen or a knight. But yeah, this is bootleg chess. This is a Wild West chess. So
Yep.
basically we just say the type of that piece is now a queen, and then the color, if the color is white, we want to have where is it? The white queen. We want to have it be the white queen.
Yeah.
The color is black. We want to have it be the black queen. Simple enough. And then we will say that, and then we want to set that file string so that when we draw the board again, then the, it'll say like, okay, we need this image instead of the previous image. Okay, so now that we've covered everything in app, I believe, let's go back. So basically what this is all in the loop, right? I guess we would add the up 1. So this is the location, right? So the location class has this x and y variable. You want to say, okay, res.add up 1. So we're adding location objects to the result. If that makes sense.
Hmm.
So all the moves, so let's say we have, whose move is it? I guess it's a king you have to take. And then let's say with a bishop, so this is a possible move, so it's added as a location object with x and y coordinates, and the same here. So now, okay, you can only move up 1, or you can only move up 2 when you're at the starting position, if you can move up 1, right? Simple enough.
Hmm.
Um, yeah, so only if you can move up 1, or you can only move up 2 if you can move up 1, and then this is basically just a check here. Okay, and then we
Yeah, that
check
makes
the
sense.
diagonals, so we say upright, right, if we can take on the right or take on the left. And yeah, okay, now here, you're gonna see this a lot. If look for check, and we're gonna say res equals find checks. This checks for a pin. So
Oh, that's
basically what
important.
this
Yeah.
does, yeah, this checks if you're in a pin, because if you're pinned, obviously you can't move. So let's say, let's simulate a pin here. Let's say, I don't know, let's say it's here, and then let's move this piece up, and then let's say this, and then this. So this piece, this pawn is pinned to the king, right? Can't move that pawn.
Yeah.
So that's basically what this checks, and this will happen for all the other what am I saying? Pieces. So if we
Hmm.
had like, if the knight was developed to this square, then we couldn't move the knight
Right.
because our king would be in check. So now we look at knight moves. So knight moves is basically all combination of, -2 +2 and -1 +1.
Mhm.
So that's basically just what all these location things are. Oh, let's take a look at helper. Actually, helper's a good thing to look at. So helper, this made it a lot simpler to just see if, I could just call this function whenever I wanted and just see like if it was in bounds, if the location, right? So we pass in the location as an argument and we're saying, okay, if the location is in bounds. So what does that mean? It basically just means that the x coordinate is not less than 0, or it's in between 0 and 7, and the y coordinate is also in between 0 and 7. That's all that means.
Yeah.
So then
Hmm.
we are going to say, so long as that location is in bounds, we're gonna say if there's not an occupied piece here, so equals null means that it's an empty square. Then we're gonna say,
Mhm.
okay, we can add that location into the list of location objects that we have. And then if the piece's color is equal to the opponent's color, so if it's white's move, and let's say in this example, I guess you have to block the check. Oh wait, there wasn't even a check, but let's say, what exactly am I checking? Oh yeah, so if this bishop here went to take this pawn, oh wait, I should probably try and take something. So let's say the queen took this pawn, that means it would stop. So it basically cannot say, okay, I'll just keep going till I get the king, basically, because there's
Oh, okay.
objects in the way, right? So that's what this says. So
That
if the
makes
color
sense.
is
Yeah.
equal to the other color, then we add the location, but then we return false. So when we return false, this basically means not for the knight moves, but when we go on to the bishop moves. So the knight moves, okay, we do the same thing and we look for checks, right? So when we go on to the, oh wait, this is the bishop moves. Yeah, this is the knight moves, this is the bishop moves. So basically what happens, right? So when we have a bishop here, or let's say that we're using this bishop, basically we want to keep moving until it's either out of bounds or hits an opponent's object. So if it goes like
Yeah.
here, then and then, yeah, that's a valid move, but then it can't go like up here, right? There's no
Right.
square.
Right.
And then we can go this way, and then once it hits this one, oh, we can't move any farther. And then
Yeah.
similarly, we can move down here, but we can't move here, obviously, because our own rook is covering it.
Right.
So that's what the helper method does, in short.
Hmm.
And so basically I've set variables here for the bishop moves, and you'll see that very similar for the rook too. So it's just saying that, you know, there's four directions, right? You can move this way, this way, this way, or this way.
Yeah.
And all you need to say is that, okay, um, I can move, in these directions so long as there's an empty space or I hit an opponent's object or an opponent's
Right.
piece. Otherwise, you can't move. So that's what this does basically. So it sets these locations so long as, let's say, so long as the up left is true, then we say, okay, we can move or we can set the location to be, farther up.
Yeah.
So we're saying in between 1 and 7. So let's say the bishop was where the rook is right now. Then we would say 1, 2, 3, 4, 5, 6, 7 is the maximum amount of distance it can travel.
Right.
So that's, yeah. So that's the maximum distance. So we want to say, okay, loop it 7 times. So basically the same thing for the rook. So we're just going to say, okay, if obviously this rook is trapped by its own pieces, so it shouldn't be able to move anywhere.
Yeah.
I guess none of the rooks can move anywhere, so that's not fun. But if we do this and then take this, this rook can move up until it hits this, this
Right.
object, which is the black piece. Right? So it can't go here, for example. That doesn't make sense. It can only go, to this square, to this square, this square. So I'm gonna take. And then we go into the queen. So this is a very simple function. So we just say the queen's moves are a combination of rook and bishop moves. So we just call the bishop moves and we call the rook moves function. So we're basically just reusing that code. So we're just saying, okay, if it's a queen, okay, we want to find all the bishop moves. So, if it could travel up right, up left, down right, down left, great. And then if it could travel up, down, left, right, amazing,
Yeah.
fantastic. Then go into the king moves. This is where it gets a little bit interesting. So basically the king moves, right, are the queen's moves, but only with a certain distance attached to them, right? So
Right.
we use a distance formula. So basically, you remember the old distance formula, like Pythagorean theorem type stuff?
Yeah. Yeah.
That's what this does. So
Okay.
if we have the king, let's say the black king, right?
Uh-huh.
So the black king can move in this kind of square here.
Yep.
And this here would be like, let's say you made a triangle, so it's like this. this kind of triangle.
Right.
So this distance would be 1, this distance would be 2, or 1, oops, and then this distance would be square root 2. So basically what we want to say is we want to say if the distance is greater than square root of 2, we want to remove that location. So we don't want the king traveling all the way over here. So
Right.
that's too far. So the distance formula will fail. Or it'll say, okay, that's way too high of a distance, get that location out of there, basically. So, it's gonna say, okay, if the distance of the king's, or the current location, oh wait, okay, the res is gotten from all the possible queen moves, and then if it's saying, or it's saying for each location in all the possible queen moves, if the distance from that location to the king's location is greater than 1.5, so root 2 is around 1.4, so we just say if it's greater than or equal to 1.5, that means it's way too far, so we say remove that location. Okay, and then
Yeah.
basically we're just trying to, or I guess now in the look for check, it's a little bit different. So we're going to say we want to find the castle moves. So we want to say, okay, find castle moves. So basically we just have X and Y. Also flipping the board makes this a lot easier because instead of saying like, oh, if the color is black, then you can go this way or this way, and if the color is white, then you have to go this way or this way. And it was a little bit,
Yeah.
you don't need to check colors here, so that's very nice. So we say, okay, if the king has not moved, right, that's the only way you can castle. We're gonna say, we're gonna set some true and false statements. So we're gonna say the right side castling, okay, that's true for now, and the left side castling is true for now. So this is what, or kind of the theory behind this is that you want to, okay, say, yeah, you can castle, sure, but I'm gonna check and make sure that all the conditions are met. And if one of those
Right.
conditions fails, then we're gonna say you can't castle.
Yeah, that makes sense.
So basically, we're gonna say for I in the range of 2, so we're gonna say this basically runs with an I value of 1 and then an I value of 2. So basically what we're gonna say is that, let's say, I don't know, let's just make a move. And then we have the king, right? So the king can either move 2 in this direction or 2 in this direction to castle.
Yeah.
So we're just gonna say, but we want to make sure, right, that when we're moving this way, that we're not in check. So we want to make sure that we're not in check right now. Then we want to make sure when we move here, we're not in check. And when we move here, we're not in check.
Yeah.
And then we're going to say, I guess if you are in check, then you're going to say that, that's not going to work. Set it to false, and then you can't castle. Also, you want to make sure that the square is not occupied. So obviously we can't kingside or queenside castle, or I guess the rook is abandoned ship, but kingside castle, we can't do it, right? Because the knight is there. So when we move the king 2 over, it's going to say, oh, the knight's there, can't do it.
Right.
Set it to
Yeah.
false. Okay, so queenside castling, you need to just make sure that, this knight isn't here. So that's
Right.
what this does. So basically when the board flips, so let's say I make a move. So you see the queenside castling is on the left.
Mhm.
Here the queenside castling is on the right because the queen's
Yeah.
original square was here across from this queen. So you need to make sure of that as well. So now we're going to say, okay, if we passed all those tests, we're going to add that new location. If we passed all the tests for left side, we're going to add all those new locations.
Yeah, that makes
Alrighty.
sense.
So now we go to find checks. So remember when we were looking here, if the look for check variable, so that means that if this variable passed in is equal to true, then we want to run this.
Right.
So we could say something like equals equals true, but that's a bit kind of redundant. So we just say that because when you make an if statement, anything in the parentheses results in a Boolean value, whether true or false. So if you want to say equals equals true, then it'll say, okay, true equals true. Okay, evaluate that to true. But you can just say if true. that makes sense.
Mhm.
So it's
Yeah,
just
yeah.
a simple way to kind of just see. So now we're going to go to find checks. So for any piece, we have to find the checks, make sure we're not pinned. So basically, we're going to make a new list to remove. So if any of the moves that we make results in a check, we're going to say, hold on now, that's got to be removed. So we're
Right.
going to take that piece out. So basically, for each location in the list, right? So currently, let's say, okay, let's make a move here. And let's say if we wanted to move this pawn up, obviously we can't do that because the king is in check. So it's just
Yeah.
saying it's simulating a move. That's what it's doing. So for each location, so technically before this function is called, this pawn has two moves. It can go here and go here.
Yeah.
So it's saying, okay, let's simulate that move, simulate those moves and see if there's a check anywhere. Okay, so we're
Right.
gonna say, okay, if we move up one, there's a check. Move up two, there's a check. So we want to remove them both. So it's saying, basically, if there was a piece that you took, then actually we'll talk about that later. But so we said
Here,
that,
actually, Rav is about to be here.
yeah.
Do you want to like part two this?
I'm actually almost done
Okay. All right.
because I
All
just need to go through this and then this here. That's actually it.
right. Yeah, yeah. Go for it.
So okay, cool. So basically, this simulates it moving. So it basically says, okay, so we have these two moves. Let's move here. And then it's saying, okay, if it's in check, we want to remove the location. So let's go to the in check. So in check, just see if a move causes check. So basically what this does is it says for each piece, it says for each piece in the piece array. So it basically just says all the, all the pieces, white or black.
Right.
If the piece's color is equal to the other color, so for example, it's white's move. So if the
Yeah.
piece's color is equal to black, then we want to see all the available moves. So we want to say piece.set moves and find all those moves. But also we don't want to
Right.
look for check in this case. For example, if this
So
was,
a lot of
oh yeah,
these are like a lot of these restrictions are like condition checking. They like check the conditions and
a
then
lot,
yeah,
yes.
yeah.
So for example, if we said piece.set moves here, and if we said true, oops, if we said true here, this would never end. It actually would
Right, right.
infinite loop, which is funny because the reason for that is that if we move this pawn up, then the queen can hit the king, but we don't want to look for a check because then we don't want to simulate the queen's moves, if that makes sense. So let's say the
Yeah,
king
yeah.
was like here and there was a rook here. You moving your pawn up doesn't mean that you're fine from a check because the queen can hit your king, although if the queen moves, then your rook can hit their king.
Right.
That might have been a little complicated, but
I think I understand.
I mean, generally speaking, here is just that if it's the other person's color, and that in setting those moves and then finding all those moves, we see that if the king's location is equal to any of the locations of the queen, so if this pawn move up here, then the queen's moves, okay, would be the diagonals. Okay, we go here, we go here. Oh, the queen's location is equal to the king's location. Then we say return true. Yes, the king is in check.
Oh, okay, that
So
makes
then we
sense.
want to say remove that location. So we're adding it to the to remove list. And then, okay, so let's say for example, I took this piece instead. Obviously I can take the queen, right? So
Yeah.
basically what this simulates, but let's say let's say there was, let me do something like this. Uh, okay, so let's say I wanted to take this queen, but there's a rook here. Let's say there's a rook and it was beaming down the board, so I was
Yeah.
pinned. I couldn't take the queen or let's say I wanted to take the queen, so we would simulate that move by saying, okay, currently the queen will be dead. So we're
Yeah.
saying, okay, the occupied piece, if I were to take the queen, the occupied piece would be set to false. It's alive status, it'd be dead.
Yeah.
So then we want to see if that causes check. If it does cause check, that's unfortunate. But then we want to make sure that the queen's not permanently dead. So then we set the occupied piece alive to true.
Huh?
So after that, then we just say, okay, for all the locations that we need to remove, just remove them, and then set the piece's coordinates back to the original coordinates that it had before. I mean, really, that's pretty much it, I believe.
That's actually really interesting.
I don't know if you had any more
So,
questions.
well, I'm just curious, like you're in the when you set it all up, do you like make the game first and then you go back and add all those restriction condition checking and everything? Is that like the way you
The
do?
ideal way to program is like doing a little bit at a time.
Oh,
So
okay.
first, I made the grid,
Yeah.
which was oh geez, it's like all the way up here, isn't it? Oh wait, this is the wrong thing. So first I made the grid, so that was this part here.
Right.
It was simple enough, you just add some rectangles, and then you have to just kind of go piece by piece, so you have to figure out what you want to do next. So you can either, add all the pieces, or I mean that's actually pretty general. So it's either you want to set up the pieces like we did here, so
Yeah.
make all the piece objects, and then you want to make sure that works, and then you want to say, then you want to draw the board, and you want to make sure that you can actually draw the board without moving any pieces first. You just want to make sure that the board is drawn correctly. And then you can get into all the moves of each piece, all the kind of conditions you need to satisfy, and all that stuff. Because I ran into so many problems where literally this would happen. So this would happen. So let's say I did this and I did something like this, and I moved the queen, and I did this. The queen could go and take the king.
Wow.
Yeah, that was the thing. So I was like, something is so off here. And
There needs to be the conditions.
yeah, I need to check my conditions big time. So that was pretty funny seeing that, and then just learning all these things in this project. So yeah, thank you,
Yeah.
Sven, for joining me.
Yeah.
It's a
Yeah.
pleasure.
And thank you for explaining. It was actually very interesting.
Cool. I'm glad you enjoyed.
Yep.
All right, man. Have fun with the
All
rad.
right.
Tell him I
Yep.
said
Thank
hello.
you. Sure will.
All right, man.
All right.
Take it easy.
Peace. Yep. You too.
Nice speaking to you.
Yep.